Last week, we created this simple game. If you remember from the yesterday, Eric showed you a sample from the whack-a-mole game, your second assignment, which is somehow similar to this project. So there are a couple of characters on the screen, and you need to find them and click on them to win scores. In this game, currently, whenever you click on the butterflies, they start flying. So it is somehow similar to your second assignment. But today, we are not going to add anything into this game. Today, we just want to teach you how to organize this project. Currently, all the instructions for this project have been written in one file. But if you go for your next assignments, probably something your last assignment have at least, I don't know, 1,000 lines of code or 500 lines of code, something like that, something like 10 times more than this. So it will be a mess if you write all the instructions here in one file. So today we are going to learn how to organize our projects using object-oriented programming concepts. Object-oriented programming started from 1980s, and after a while, all the programmers realized that if they spend more time while writing down their codes to organize their codes based on the object-oriented programming definitions, they will have much less errors when they expand their codes. Let me start from your code. For example, for your first assignment and for the part 3 of your first assignment, how many lines of code did you have in your code? Do you remember? About 100 lines of code, 200, 400, okay. Anyone else? 500, okay. So imagine it goes to something like 10 times more, so it goes to 4,000 lines of code. Then imagine you are just going to add one more variable into your game. For example, one of your methods, you have many methods in your game, is going to send a data for another method. You need to define a global variable to talk between these methods. So probably if you have something like 4,000 lines of code here, you need to go all the way up to write your variable, your global variable here, and whatever it can be. And then you need to go all the way down to your first method and write a value inside this variable. And then you need to go all the way down to the other method to use this variable. So you all the time are going up and down, which is really tiring. And also you might do some mistakes. For example, whenever you are going to show your butterflies here, you might mistakenly, instead of n, which is the number of your butterflies, use m, because m and n are neighbor keys on your keyboard. So just imagine changing one of your variables into another variable makes everything complicated in your game. So the programmers start designing object-oriented programming to reduce these kinds of errors in their codes. Usually, every programmer has something like in the standard, have something like 70% of time they need to spend to fix their bugs. What about you? Do you remember? Can you give me a rough estimation how many percent of your time for your assignment 1 spent over debugging your errors? 10% of time? 20? 15? 30? Usually because your first assignment is a simple assignment, you don't need to spend something like 70% of your time. But as I know from the last semester, many students spend something like 50% of their time for removing the errors. So if you had this kind of a lot of time spent on your errors, don't freak out, don't be frustrated, because it's what it is. Usually we programmers are more like debuggers than programmers. So we program 30% of time and debug 70% of time. So as a programmer, you need to learn how to be friend with your errors. Don't be panicked when you find an error. You should have some sort of systematic way which helps you to how to track your next error and how to fix that. So all these organizational things, I'm going to talk about them today, and all the object-oriented programming concepts, all of them have been designed to reduce your errors. And for example, if by adding object-oriented programming design into your project, you can reduce the amount of your errors from 70% of time into something like 50% of time, it will be really beneficial for you to use object-oriented programming. So that's the reason why programmers spend that much of time to organize their code. It also helps them to, for example, later, whenever 6 months later, when they want to return to your code and, for example, change something, if you write 4,000 lines of code or 5,000 lines of code all in one file, you can never find one specific line of code you want to change. It always happens, for example, in big companies, the customers calls them 6 months later and then say, okay, we added a new branch to our company, so we need you to change our program in a way which can fit our new branch or new product. So the company need to return to that code which have been written 6 months ago or 6 years ago, and you need to be able to understand what exactly you written there. So making your code more readable is another reason why programmers design object-oriented. Okay, based on this part, let me explain you the simple reason for using object-oriented. The simple definition of object-oriented is that instead of putting all the codes and variables inside your main inside your file, your main file, divide them between different files. For example, instead of these 5 global variables in one file, put some of them in another file. Instead of all these instructions here, put some of them in another file. In this way, by dividing your variables and instructions in different files, you can manage your errors much easier. So how we should decide which variables should go into the other file and which other variables should stay here? That's the main idea behind object-oriented programming. Object-oriented programmers believe that every program is going to simulate something from the real world. For example, in this game, there are many variables. All of them are float or integers. And also, there are many, for example, assignments, rectangles, and also calling methods for, if, also I can see some rectangles, arcs, lines, but these are as a processing, you see, all the programs have some float and integer variables and some instructions in them. But when you show this program to some human being, they don't talk about the lines and the arcs and the variables. They talk about some butterflies they see on the screen. Because human beings believe that this program simulates some things from the real world, which are called butterflies. So even if 6 months later, you can't remember any of these variables or lines of code. But whenever you see the result, you know that there are some butterflies in this game, in this project. So if you are supposed to divide some of these variables and instruction into another file, it might be good to that file will be specifically related to the things your program is going to simulate from the real world. For example, in your project, because your project is going to simulate butterflies, creatures from the real world, you can put all the variables for the butterflies and also all the instructions related to the butterfly into another file. To create a new file, you need to create on this small triangle here, and then click on the new tab, and then it asks you a name for this file. It's very important to choose a meaningful name for your project. For example, because this project is about butterflies, is going to simulate butterflies, I choose the butterfly name for my new file. But for your project, if you are going to create some aliens, your file should be alien. If you are going to create some flowers, some clothes, some everything, you need to put those variables and instructions related to your character in your second file. So that's how the object-oriented helps you to find which variables should come into this file. Whenever you create a new file, you need to also define a class with the name of this file. So if your file is called butterfly, always put your class name as the butterfly. So now, between this open curly bracket and close curly bracket, it's the place to put any variable and instruction you want here. Just bring all those variables and instructions from the main file, main sketch, this file, into the butterfly. Let me start from the variables. Between all these variables, whenever you are going to decide which one should go to the other file and which one should stay, always think with yourself, each butterfly in my game contains what? A specific parameters or fields. For example, each of your butterflies needs its horizontal coordinate or horizontal position. Each butterfly have a position on the screen, a horizontal position and a vertical position, which shows specifically where exactly your butterfly is on the screen. And also, each butterfly has its own speed. So you need to bring X, Y, and speed here. I can just write them in front of them. But does each of your butterfly has its own butterfly width, or all butterflies have the same width? If, for example, one of your butterflies is 100 pixels width, but the second one is 200, then you need to bring this variable into your butterfly class as well. But if all your butterflies have the same width, you don't need to bring that variable there. So you can put it here. So always remember, any variable which each butterfly should have, one of them should go to the other file. What about the n? The n in this code is the number of our butterflies. So we should bring the n into the butterfly class if each butterfly should have its own n. Or if I want to put it in another way, if each butterfly should have its own number of butterflies, then this n should go to the butterfly class. I don't think the answer to that question is yes. There is only one number of butterflies in my project, which is 5. It's not like the first butterflies have 5 butterflies and the second butterfly have 10 butterflies. So there is only one variable. So this variable should not go inside that class. That will be the same for all your characters. So for example, if each of your butterflies have their own scale, you should define a scale here. If each of your characters have their own rotation angle, you need to define rotation angle here. But if there is only one rotation angle for all the characters, you need to define that here. If each characters have its own color, you need to define the color here inside class. But if all the characters have the same color, you need to define that color here. So does it totally make sense? Can you do that for your project? Because it's very important. You should be able to understand which variable should go inside the class and which variable should not go there. Are there any questions? All answers yes. Okay, so we only bring these 3 variables here, and now instead of defining multiple x's in my project and multiple y's in my project and also multiple speeds in my project, how can I define them based on my butterfly class? It seems that I don't need this variable anymore. I can press Control and if you have PC, Control plus this button, the comment multiple lines of code. If you have a Mac, it should be probably Command plus this button, so you can use these buttons to comment or uncomment instruction. And if you press it again, it uncomments them. Okay, so I brought these variables them, so I don't need to define them here as well. But how can I define one butterfly here? These 3 lines of code just tells processing that whenever the programmer created one butterfly in their game, that specific butterfly should have its own X, its own Y, and its own speed. So how can the programmer define one butterfly here? Defining samples from class is very similar to defining variables from the data types. For example, as you can define a variable called p from a data type called float, and put a number inside that, for example, any number you want, you can do the same with classes. So you can define from the butterfly class an object called, imagine, for example, I don't know, current butterfly. Just you can put any number you want. So that's how you can define one variable from your class. If you define a variable from float data type, this variable has the capacity to hold one float number inside it. What about these variables defined from class? Each variable you define from a class will have 3 float variables inside that. So you can put a value inside its X, you can put another value, float value inside Y, and the last float value inside its speed. So actually, defining variables from class is very similar to defining variables from primitive data types. So object-oriented designers wanted to show you, to help programmers that always behave with the classes in a similar way they behave with the global data types. So you can, for example, define P1 and P2 as your variables. Also, you can define current butterfly number 1 and current butterfly number 2 as your samples. So now each of these 2 variables have their own X, their own Y, and their own speed. So totally, now we have 2 X's in our project, 2 Y's, and 2 speeds. And let me show you. However, if you are going to use them, you are in your game, you need to add one more instruction in them. I can show it, write it for you. So equals to new butterfly, open and close parentheses. Actually, it's similar to float p equals to 1.5. So like the primitive data type, when you define a variable from a class and assign it some values, here you can do the same here. You define a variable from the class and then assign it to something. Another important thing which you need to know that usually programmers don't call these variables as variables. Programmers call these one variables, but they call these ones as instances from the class, or they call them objects from the class. So whenever I'm talking about objects, I'm talking about the variables which have been defined from classes. Always remember these words, because later whenever we are talking about objects, you need to know that what exactly I'm talking about. In your exams or in your everything, whenever we are talking about instances or objects, you need to know what exactly we are talking about. So That's how we can define a variable from the class or an object from the class. What about defining an array? You know that we can define simple array like this. Defining simple array is like this. So I can define the simple array from float by this instruction. For example, now I create n different floats from the as an array called p. So it's similar to defining p0, p1, and pn minus 1. What about the object? Defining an array of objects. You can do exactly the same thing with the object as well. Just instead of using float, please use butterfly here. So I just copy and paste this line of code here and change the float with butterfly. Now we have an array of objects. However, probably I need to change the name of this because name is very not understandable. Let me call it butterflies, for example. So as processing understands from my line of code, this line of code is very similar to the upper lines of code when you change the float with butterfly. So it seems like you created multiple instances or objects from butterfly class. Does it make sense? You can use that. So actually, when instead of defining one array or from x, one array from y, and one array from speed, you can define only one array. Instead of these three arrays, you can define one array from butterfly. This one array have multiple n objects from the butterfly class, and each of these objects have their own x and y and speed. So it means that this simple line will be exactly the same as these three lines of code. So let me just erase all the other codes. So now we just need to, instead of writing these three lines of code, we just need to write this one line of code here. Let me just erase everything else. So now it seems that our variables are actually divided into two files. I brought three variables into my second file, and now instead of having 5 variables in my first file, I have only 3 variables here. So actually object-oriented helped me to reduce the number of variables in my main sketch. But you cannot run this code now. As you can see, there are many errors wherever you try to access the xi or yi or speed I in your project. You always have these errors because these three arrays are no more there. So we need to solve this problem. Just let me erase these comments. I guess then the code will be much more easily can be washed. Okay. So let me tell you how can you solve these errors. Whenever you are going to work with a lot of variables or objects, one easy way will be to define one local variable here. Do you remember the local current butterfly variable I designed globally? This instruction tells the processing that please define one object, one local object from the butterfly class, and this local object will have its own x, its own y, and also its own speed. So now, I can put that here. I can show it how it works here. I guess you remember from the last week that these 4 means exactly a compact version of these lines of code. So in these 4, first we initial the x and y for the first butterfly, and then we initialize the x and y for the second butterfly, and like that. But no, I'm going to change that in another way. No, I'm going to define this butterfly here, and then instead of changing x0, I'm going to change the x value for the current butterfly like this. As Eric yesterday showed you, whenever you are going to access a variable from an object, you need to write the object name, then you need to add one dot, and finally you need to write the variable names. Also, it would be good for you to know that programmers don't call these variables as global variables or variables. Usually programmers call them fields or members. So if you ever heard I'm talking about these variables as fields or members, you just need to know that I'm talking about the global variables inside classes. So no, whenever you write an object name and then dot and then one of its fields, then it means that you are putting a random value inside the horizontal position of this current butterfly. You can do the same with the vertical position of your butterfly. And whenever you assign this vertical position of the butterfly, now it's time for you to put this butterfly inside your array. So let me see, what was the array name? The array name was butterflies. So I'm going to put this current butterfly inside the first element of my array. So that's how you can put different variables inside an array. First, define local variable. Second, assign its values. And finally, using this line of code, you can put this local object into the specific position you want inside the array. For example, now in this line of code, I assigned my local object into the first position inside the array. And you need to do that for all the others part as well. For example, you need to, instead of changing x1 and y1, you can change your your current butterfly x and current butterfly 1, and then put that in your second object. So instead of just writing all these instructions, I can just write them like this. Current butterfly dot x, current butterfly dot y, and then please put this current butterfly inside the butterflies array, and the position number will be, because first we need to put this variable in the first repetition, we need to put that inside the element number 0. The second time we need to put that inside element number 1. The next time we need to put that inside element number 2, and also and until element number n minus 1. So I need to change this number with I. If you remember from last week how I designed the for, whenever one variable is changing every repetition, you need to use the for counter as for this variable. So that's how I initialized all the elements for my butterflies in my setup. Just let me erase all these instructions, comments here, so you can see everything much easier here. if I want to show you how it works, how all these lines of code works in my project, let me debug my code so it will help you to know what exactly happens inside processing memory when the processing tries to execute this project. To debug my code and show you what happens here, I will press this debug button here, and then I will see the variables window here. Also, I will click the line number 7 behind my 4, because whenever I'm going to start executing my code, I want my code to exactly stops here so I can see what happens inside my arrays and all the variables while I'm running this code. Let me press the start button. Oh, excuse me. My other parts of code, because I did not figure the other errors, they have also errors. Just let me comment all these lines of code. I don't want to solve the errors first. I want to show what happens here, and then we can go for the next part of the code. So let me run it again. Okay. As you can see here, whenever we are going to start this before this code, we have three variables: butterfly width, which holds the value of 100, n, which holds the value of 5, and a butterflies array, which you can see it here. The butterflies have n element, and because n is 5, here you can see 5 different places inside the processing memory. However, currently null is inside all of them. In programming, null means nothing. So nothing is inside each element. And now you are going to see how this for step by step fills each of these elements by the appropriate values. Let me press the step button to see what happens. I start the for, so now one element have been added to my variable list, which is I, and I started with the 0 value. And then I will press the next button to see what happens when inside processing memory I defined one object from butterfly class and knew it. When I press this object, you can see a new row is added to the variable list. It shows the current butterfly object, and if you bring it here, if you may expand the variable, you will see that there is an instance of lab3 underline complete project the $butterfly class inside this object. If you click on this plus here, you will see that this one variable holds one x, one y, and one speed all inside itself. So even if all the values are 0, but you can see that these individual variables hold all the needed parameters for my butterfly. Let me press the step again. In the next instruction, you will see that I changed the value of x into 270, a random value. And when I press the step again, you will see that now the y value is changed. So now you will have a random position for your butterfly. And in the last instruction, you are going to assign this current butterfly into the first element of your array. Let me press the step button. And now you will see that you can see a plus button behind the first element. And when you press that, you will see one x, y, and a speed, which holds the 270 and 300 there. So that's actually processing how initialize the first element of your array. If you do this process 4 more times, every time you will see that one instance from this butterfly class will be added into your butterflies array. So whenever I finish all these 5 repetitions of 4, now you will see that I have all the 5 elements are filled with different values for one butterfly. The first butterfly, this is the second butterfly position and speed. This is the third butterfly position and speed. And as you can see, I hold all the values for all my butterflies inside one array. Are there any questions? Does it make sense? How you compact all your individual variables into one object or one array? That's very important to know how the processing understands object, because later when you have some sort of errors in your code, you can use your understanding to find what is wrong in your code and where exactly you missed something which caused this problem. If there are no questions, let me go and fix other errors for my code. Let me first uncomment these lines of code. And now, I guess probably you can guess how I should fix this line of code. Because now I'm going to access all the positions and speed of all my butterflies inside this 4. Probably you can guess that I need the same approach to access all values of my array. So I need to define a local variable, and also I need to assign that local variable with one of the elements in my array. So let me do that here. First, for example, I created one local variable here. Current butterfly or next butterfly, whatever name you want. So let me, for example, call it next butterfly. And then you want to assign this variable to your next object from your array. So it should be butterfly number I. This means that in the first repetition of this for loop, when the I is 0, this local variable will be equals to the first element of your array. In the next repetition of loop, when the I is 1, this local variable will be assigned to the second element of your array list. And that's why I put here y, so it will assure me that at each repetition of this 4, I will access one of the elements of my array into this local variable. And now you can use this local variable in your game, in your project. For example, instead of drawing xi and yi, you can use the same approach here. So call your local value variable object dot the field name. So first, I guess I changed the name to next butterfly. So next butterfly dot x instead of xi, and next butterfly dot y instead of yi. Also, all other places, for example, instead of xi here, I need to write next butterfly dot x, and instead of yi, I need to write next butterfly dot y. Also, instead of speed, I need to write next butterfly dot speed. And here in this line of code, I need to write next butterfly dot I plus equals to next butterfly dot speed. And now all the errors have been fixed. And now you can see the result of this code by running it. Nothing is changed from the lab 3 underline complete. The only thing is changed is that now your code is more organized. Now all your variables have been divided into two classes, and now your code works with the same result. The only thing is that now your variables are divided into different classes. Please implement that in your computers. And if you have any question, please raise your hand. I will help you. Are there any questions? You need to define one array from butterflies, and then you need to change your code like this to see how it works the same. Okay, yeah, you can ask me your question. Oh, you want to show me something? Okay. Whatever you don't understand when I'm explaining, you can just raise your hand and ask. So don't be that much quiet, because usually I prefer to students ask me questions so I can know what is exactly what. Why? Can you see how I realize what's wrong from watching the result? So, for example, if they were here, it means that the y is different, but the x part of them are zero. So now we will change the first one. So always try to understand what's wrong by watching the result. It helps you instead of just watching there, because you need to do that for your project a lot, your assignments. So always try to understand what's wrong based on knowing the logic behind the code. Okay, do you need more time to implement, or it's good, we can continue? Okay, so I will continue. So far, we learned that object-oriented programming means 3 steps. First, find the concept which your program simulate from the real world and define an individual file, including individual class for that specific object concept, which in our game is a butterfly. Second, divide your variables from your main file into this file. So bring every variable related to this concept into this file. And now we are going to go for the last step of object-oriented programming. In the last step, you are supposed to bring any instructions related to this thing from your main sketch into the butterfly class. So now it's time for dividing our instructions between different files. The concept, the idea is the same. Always bring the instructions which are exactly are supposed to be executed for every butterfly in your game. Very similar to this X, we brought this X, Y, and speed here because every butterfly has its own X and Y and speed. What about the instructions? For example, if each butterfly has its own setup method, bring the whole setup method into the butterfly class. But no, I guess there is only one setup method for the whole program, which will be executed only once at the beginning of the program. So never bring your setup methods into your other classes. What about the draw method? Does each butterfly need its own draw method? So 5 butterflies need 5 draw methods? No. Draw method is only once and for each program, and it will be executed at each frame of your code. So never bring your draw method from your main sketch into any classes. What about the draw butterfly method? Does every butterfly should be drawn by this instruction? Each of your butterfly should be drawn in your project by this instruction? Yes. As a matter of fact, for each of your butterflies in your game, you will call this method because you need that specific butterfly will be shown on the screen by calling this method. So this method should be called for each butterfly. That's the reason why you need to bring this method from your main sketch into your butterfly class. Please cut the draw method and bring that into the butterfly class. Please be cautious. Don't put that after close curly bracket. So now this method is outside the butterfly class. The butterfly class is between this open curly bracket and this closed curly bracket. So please put this method between those curly brackets. So now it means that this method is inside your class. If you want to organize your code or format your code, you can go to the Edit menu and click on the Auto Format. Or you can simply click Ctrl-T and it will auto format your code. So now I brought one of my methods here, and as you might expect, now we have an error in our code. If I click on this line of code, I will see the error description here in red. The function draw butterfly does not exist. That's true. The draw butterfly method is not existing in my main sketch, but it is in the butterfly class. So how can I call this method in the other class? Let me change its name. Usually, whenever you are going to draw an object, we call the draw me some simple name. So because each butterfly should be drawn on the screen by calling this method, we call draw me. So just calling this method simply draw me don't solve your problem. Why? Because processing don't know. If processing cannot find this draw me method in the main sketch, which other file processing need to search to find this method? If you want to guide processing where exactly processing need to find this file, you should do the exact same thing here. Do you remember when you wanted to assign a number inside the speed, and if you don't write anything behind the speed, processing tells you that the variable speed does not exist here because processing does not know where is this speed. And to let processing know where it can find the speed, you added the object name from that class before this variable. So you need to do the exact same thing here. So if you want to tell processing that, please go to the butterfly class and call this method there, you need to write name of an object from the butterfly class and put a dot after it. Now your code is working and processing knows that. Processing need to go to the run this draw me method for the next butterfly object. So there is no error, and if you run this code, you will see that your game works exactly similar to it was before. But the difference is that now our code is much more organized. Our instructions have been divided between different files. So that's how you can call a method from another class. Very similar to how you can call a variable from another class. You just need to write the name for your object and then dot behind the method name or variable name. By the way, one more, that's it, like that. By the way, object-oriented program designers created many useful techniques to make their code less complicated. Because as I already told you, object-oriented programming started from 1980s, and then from that time, object-oriented programming designers designed many techniques to help programmers to reduce their complexity. For example, one of the useful techniques here is that if you notice, inside the draw me method, we are supposed to draw our butterfly in the X and Y position. And even if this X and Y position have been accepted currently from the parameters here, but we know that these parameters, this X and Y, are exactly for the same object as this method. So this draw me method is called for the next butterfly, and we want to show the X and Y for the next butterfly here. So if you have the same situation in your project, you are going to access the fields of an object inside a method of that object. You don't need to write any of these parameters in your method. Why? You can erase them and your code still is working. Why? Because, as you know, methods always will have access to their global variables. So now in our game, this X and Y and speed is something similar to global variables for draw me method. So whenever you write translate X and Y inside draw me method, processing automatically uses the global variables here. You might think, okay, even if I define one X and Y and speed inside butterfly class, but I know that there are several different X and Y and speed in my game. Each butterfly has its own X and Y. So how processing knows that when I tell, please use the X and Y, how processing knows that which X and Y I'm talking about? How processing detects that? The answer is that whenever you access the fields, the global fields inside the class method, processing always automatically access those fields which are for the same object that you call this method for that object. For example, because in your game you call this drawMe method for the next butterfly object, the processing use the x and y for this next butterfly object inside the drawMe. So it means that if, for example, two butterflies are about to fight together in this game, then your next butterfly should know the position of the enemy butterfly. So how inside this drawMe method you can access both the position of our current butterfly and also the enemy butterfly? So there are two positions, two x's and two y's. How we can access them? As I already mentioned, whenever you write these names, x and y, it always refers to the current object. So for the enemy object, you need to send the value for other objects. For example, if you have another butterfly like enemy butterfly, you need to send those objects fields separately inside this method. So don't forget, if these fields are for another object than the method object, you always need to send them. This rule only applies for where you fields are the same as belong to the same object as your method. Is it clear? Yes. Excuse me, what? If I send which value? Okay, enemy. Prefer. Let me show you. Okay. For example, imagine my next butterfly is something, this one, and I'm defining another butterfly called enemy butterfly. Actually, I did not have any butterfly here. So enemy butterfly. So I know that this enemy butterfly currently is 0, but I want to send this enemy. So I write enemy butterfly dot x, comma, enemy butterfly dot y. And now I send them here, and here I need to accept them. So there is a object, excuse me, a float x and float y. Just let me to make it clear, enemy, x enemy and y enemy. And now, whenever you talk about x and y, you always talks about the x and y for the next butterfly. But if you are going to access the x and y of the enemy, you need to use this x enemy and y enemy. Does it make sense? So whenever you just write x and y without any prefix or anything, you always refer to the x and y for the current object which this method has been called. Because you have been called this method for the next butterfly, this x and y refers to the x and y of this next butterfly. Does it make sense? So for all other butterflies, if you want to access them, you need to send them by parameters into your game. And now you can use the x enemy and y enemy inside your method. These are very important because later in your next assignment, you are supposed to interact between different butterflies, and you need to know and use them in your assignments. Any other questions? Okay. Let me practice this calling method again. I want to be sure that all of you know how to do that for your projects. Let me just delete this enemy butterfly. Okay. So for example, which other instruction we can send into this butterfly class? For example, whenever you are going to access the values, the fields of an object, so whenever in your main sketch you are accessing x, y, and a speed of a butterfly, probably that specific instruction will be a good candidate to be sent to the butterfly class. For example, here I'm accessing the y and speed of my butterfly, so I can send this instruction in that class. How I can send them? Because first, when we wanted to send the draw me here, the draw me was a separated method here. But this instruction is not separated. So you need to define your own method here. For example, if you want to send him here, you can make a method. You can call it whatever you want. And then you can send this method here. Let me call it something, for example, because this instruction is going to change the position of butterfly based on the butterfly speed. It's actually moving the butterfly. So let me call the method move. And now you can call this move method here. However, you will face the same error here. Processing does not know where is the move method, where processing can find this method here. So you need to write the name of your object. So you need to use the next butterfly dot move. In this way, you don't need to use this name next butterfly dot. So you can just reduce this instruction to this simple line of code. Just y plus equals to speed. And processing knows automatically that you are going to change the y of this butterfly, this next butterfly, based on the speed of this next butterfly. So because you call this method for the next butterfly, processing all automatically access to the x, y, and speed of the next butterfly, allow the access to all these three fields inside the move method. So that's another example how you can bring instructions in your class. All these examples help us to know how can we divide these or the instructions between different files or classes. Let me do that again. The next instruction can be this one. We want to change the speed of the butterfly. As I already mentioned, whenever in your code you are changing the fields of an object, that instruction will be a good candidate to be brought to this class. So I'm doing the same here. I will cut this from here and put that into a method here, void. Okay, so we need to find an appropriate name for this method as well. Because now we are changing the speed of the butterfly, probably change speed will be a good name. So I put this instruction inside a method, and here I will call name of my object dot change speed. Very similar to name of the object dot move or name of the object dot draw me. All these methods can be called the same manner, or name of the object dot x, name of the object dot y. We can also bring these two lines, these two into the butterfly class, but it might be a little bit complicated because these are only two arguments for this distant method, and this distant have been used in if, so just put it there. You are not forced to bring all these lines of code there. However, you can do that, but for the sake of the time, we don't do that. Are there any other position in the games we can? Just search for every place which you access the x, y, and speed of an object in your main sketch. I guess the last part is this part. as you can see in these two lines of code, we randomize the X and Y fields of our current butterfly. So we can bring these two lines of code inside our class. And then call this current butterfly dot the name of this method. Okay, so let me find a good name for this method as well, because I'm going to put some initial values for the position and speed of the butterfly. Let me call initialize. And instead of just writing the object name dot, I don't need to put them here. I just can write the name of the object and then dot call the method name butterfly. Okay, now it's working. So I guess now we have enough examples on how we can bring lines of code from our main sketch into our classes. This is bringing the lines of code from your main sketch into your classes is the last step of object-oriented programming. So you should do the same approach for your game projects, your assignments as well. However, you can make this code better. For example, these methods are not very flexible, so you can make them a little bit more flexible. For example, whenever you call this change speed in your project, it always changes the speed of butterfly to -5. As you can see here, the speed always goes to -5. So if you want to, for example, I ask you to right click on the butterfly to change their speed to +5, you cannot call this method because this method always works with -5. So if you want to use this method for other situations, you can use parameters there. For example, instead of always choosing -5, you can change it with a variable, something like s. However, you need to define this s as a parameter here. And then, instead of always calling this without any parameter, you can send -5 as the velocity or the speed of the butterfly. No, the result is exactly the same, but my method is more flexible. It means that no, I can call this method. For example, whenever you right click on the butterfly, I can change the butterfly speed to +5, or I can stop butterflies from moving by 0. So no, my methods are more useful, can be more useful in my project. You can always use this, add this kind of parameters to your methods to make them more flexible and useful for your project. If I did not use this method here, but if I wanted to, for example, bring my butterfly down by the right click, I needed to create another change speed to change speed to always +5. But here, instead of one change speed with -5 and another change speed method with +5, I just combine all these two methods inside one method, which can accept one parameter as the speed and apply that to the butterfly speed. You can do that with the other parameters. For example, here initialize. Instead of this initialize, always initialize your butterfly in a random position of the screen. If you want one of your butterflies to be in the center of your screen, you cannot use this initialize method. So you can, instead of just always using randomized variables, you can define parameters as well for the x and y, and then okay, so probably I need to change the position, probably x position. Let me change their name because I don't want them to be confused. Okay, so x position and y position. And here I can define, for example, float x position equals to, I just define the random position for x, and also I define the random position for another value called y position. And now I'm sending this x position and y position. So now I brought these two lines of code back into my main sketch. Instead of bringing them inside the butterfly class and make my code, my main sketch smaller, I hold them here, but I also define the method. So now my method can be much more flexible. So now I can, for example, create another butterfly in my game. For example, butterfly, another butterfly, you can call it enemy butterfly, and create it in the exactly in the center of the screen. You don't need to write this down. I'm going to show you how it works. Like dot initialize, for example, width divide by 2 and height divide by 2. So you can now use the initialize for other types of initialization as well. Are there any questions so far? Please implement this. Code. And if you have any error, please raise your hand. Oh, by the way, you can change the speed as well. So let me initialize the speed with probably S. Or no, let me teach you another useful technique by the object-oriented programming, and then you can implement that in your code. Because as I already mentioned, there are many techniques in object-oriented programming which can reduce your effort while programming. For example, one of them is about to using different names for your variables. As you can see, first here I use my parameters as x. If you remember, first I defined it as x, but then I remembered, okay, oh my god, I cannot use the same x here because I have already one global variable called x. So if I define this parameter as with the same name of x, no processing does not know which x should goes inside which x. For example, is my parameter should goes inside the global x, or my global x should go inside the parameter x. So if you, but it is easier. So probably you can use different names. The simple answer will be to use different names for your parameters, but it's also make programmers a little bit confused because now you need to remember, okay, so what is the x pose and what is the x? X is the global field for the butterfly, and x pose is the parameter. So remembering two different names make the programmers more distracted, and it can make other errors in the other codes because human being cannot remember more than 7 or 8 or 9 different things in their mind. So don't waste your memory for the same variables with different names. So how we can solve that? The object-oriented designer told that, okay, It's okay if you define, if you give the same name of your class field to your method fields. But in order to help processing not be confused, please, whenever you are referring to the class field, please write this dot behind it. So now the processing knows that this X is the class field for the current object, and this X is the parameter X. So whenever you use the X like this, it always refers to the local variable, which in our method is the parameter. And whenever you are going to refer to the global variable inside the class, you need to write this dot x, which means that this object, this current object, dot field x. So that's one simple technique you can use in object-oriented programming. In this way, you don't need to choose different names for your variables. You can change all of them into similar names. No, and also you can put different names as well, whatever is easier for you. So you can use here as well. That's one useful technique. Here you also can change this S into a speed if you use this here. Or another useful technique. Okay, I guess now you can implement these lines of code. These are the almost finalized. Okay, but there is initial something. Oh yeah, when I define 3 parameters here, I always need to send x and y and the speed. So the speed for all butterflies is 0 at the beginning of my code. So all butterflies are stationary. So now it's working. Okay. So please write down these instructions. Oh, you want to write the main. Okay, yes. Great. Okay, you can write here. However, I can make this part better. So, yeah, you don't need to write these 2 lines of code because I'm going to compact it more. If you write it down, you probably need to change them. There are, as I already told, there are many different techniques. Yeah, you can write that. Later, you can erase your code whenever I change. Yes? Please, if you have any questions, raise your hand and yes. Oh, okay. It's good? Okay, it's almost. It's good? Okay.
Up there, under your butterfly initialize, why is it still when you have
Oh, this x pose and y pose are local variable, these 2 variables, which I've defined here. So if you want to change their name, and I actually suggest you to do that, you can use the x as well here. You don't need to. So in this way, whenever we are talking about the x, we are talking about the horizontal position of the butterfly, either in the main sketch or inside the global class, inside the class fields, or inside the local variables. So always, whenever you are referring to the horizontal position of butterfly, you always say the name x. So that's actually a better way. Thank you. The next one, what? Oh, you need a help? inside the drum. So it has one. But you add this. Yeah, that's one of the CV errors of processing. Any other? Are you good? Good. Okay. So let me go for the. Okay, yeah, let me teach you about this part. Another useful technique, small technique, object-oriented programmers use is that after something like, I don't know, 5 years, a couple of years, programmers realize that whenever they create an instant or object from a class, they always need to initialize that. Because, for example, it does not make sense to create one butterfly, but this butterfly is nowhere. Each butterfly should have a specific value for its position and speed. So it does not make sense to define a butterfly, but don't initialize that. Not only for your butterflies, for all the characters, for every object you create from a class, you usually need to initialize their parameters. So they thought, okay, it might be good to define something similar as setup method for each class. You know that the setup method will be executed only once for your project when your project is started. So it would be good to create a method for each class which can be started automatically only once after you create an object from that class. In this way, you can put your initialization instruction inside that specific method, so they will be executed automatically. So you don't need to use 2 lines of code, first to create one object and second to initialize it. Just whenever you create the object, one automatic method will be executed automatically inside the class and just put all these values there. So they call this method, this kind of, it's very similar to setup method, but for a specific class. They call this constructor method. And if you notice, this name for the class and open and close parentheses for the class is very similar to name of a method. For example, as you can see, when we call this draw method, every method has a name and the open and close parentheses. Or this initialize has a name and then open and close parentheses, and you can put any values you want, arguments you want inside that. So they thought, okay, let us make, let us allow programmers to define a method with the same name of class inside each class. So whenever you want, this instruction will be executed for all objects defined from the butterfly class. The only thing you need to do is that change the name of this method to the same name of the class. In this way, processing knows that this instruction should be executed only once whenever one object has defined from the class. By the way, remember that whenever you define a method in this way, you should not put any word behind that method. So never use void the name of method. As you can see, all other methods have a name behind them, like this. But never put void behind this method. No, as you can see, method processing automatically detects that this method is like a setup method for the butterfly class. So whenever you create one object from this butterfly class here, those 3 instructions will be executed here. And if you want to send any variable arguments, for example, this method, as you can see, needs one x, y, and speed. So if you want to send those data here, you can send those 3 values directly inside these parentheses. So you can write your parameters here, and they will be assigned to this object. So by this technique, you don't need this line of code anymore. Let me just erase that line of code. So defining constructor is a useful way whenever you want to assign different fields of an object to initial values. Now I guess our program is pretty much good organized. I guess this is the best way you can organize this code. Everything is very similar to what we had last week, but no, our code is much better organized in this way. Are there any questions? If you have any questions about even the concepts and any ideas, you feel free to share, because this lab has much less students at the class, so you cannot ask all your questions in the class, but here you have more time, you can discuss all these concepts, so it helps you to understand those concepts much better. Okay, if there are no questions, let me go and do the last part of this code today. The code is good enough organized. I just want to introduce you to a new array, which is called ArrayList. I guess Eric yesterday talked about that. For your assignment, for your VAC-Evolve assignment number 2, you cannot use array, because when you define array, for example, this array, because you define it with n elements, you can only have 5 butterflies in your game. So you cannot have 6 butterflies. You cannot put 6 butterflies in this array, or you cannot put 4 butterflies in your game. So whenever you create one new butterfly, you cannot hold that information inside this array. Or when you click on one of your butterflies and you want to destroy that butterfly, you cannot reduce the length of this array. That's the bad thing about the array. So it might be better to use another type of array, which called ArrayList. The ArrayLists are very similar to array, with this difference that they don't have any element inside them, and then you can add as much as element you want, or you can remove as much as elements you want from them. So they can hold as many as elements you want. So see how I define this array list. Actually, it's very easy. So you need to start array list. Okay, so that's how you can define array list. As you can see, there is no mention of n or any other numbers. So when you define array list, those are like empty arrays. There is nothing there. And if you want to add elements to them, you need to add them one by one. Like this line of code, as you can see, whenever I want to add one element, for example, I want to add the current butterfly into the butterflies array list, instead of writing this syntax, I need to write dot add open parentheses current butterfly close parentheses. This is the way you can add one more element to your array list. Every time this line of code will be executed, you will add one more element into your array list. And when you want to access the elements of your array list, as you can see, it's not working like the element number I, but instead you can write ArrayList dot get open parentheses I close parentheses. So this in this line of code gets the element number I from your array list. So that's it. So now our program works with array list. So it means that now you can add, for example, if I clicked, you can add a line of code if the, for example, the player clicked, then add one more butterfly in a random position to the game. Or if you click on one butterfly, please remove. For example, if you right click on the butterfly, please remove that butterfly from this array list. If you want to remove a butterfly, you need to write these instructions. Very similar to this add. So let me just write the remove. For example, if you want to remove one butterfly from array list, you need to write, for example, remove, for example, element number I, for example, element number 0 or number 1, whatever element you want, you can remove that specific element from your array list, but calling the remove method. So that's the last instruction you need for working with your array list. Oh, by the way, one important note, because, for example, for your array list, you can start with n butterflies, something like 5 butterflies, and add them one by one into your array list. But later, in the draw method, when you are going to show these butterflies, you cannot show always n butterflies, because array list might be, after each click, might be bigger when you add one butterfly into it, bigger than n. For example, you add the 6 butterfly, 7 or 8 butterfly, or if you remove those butterfly from array list, it can go less than n, or 4 butterfly, 3 butterfly. So don't use a static number for array list, because every frame, for example, at the beginning, at the first frame, yeah, that's 5 elements inside the array list. But for the next second that you add or remove some of its elements, there will be no n elements inside that. So always programmers use array list dot size. So whenever you are going to show or check all the elements inside the array list, always use array list dot size instead of just one variable. Or else, for example, if you have reduced the size of your array list to 4 and then try to show all the 5 elements of your array list, because there is no element number 5, you will face a runtime error in your code. So that was everything about the array list. There is nothing left for the today class. Excuse me, today we had covered a lot of concepts, but it is important, as you will realize in your next assignment, you are going to work with all of them. But as your lab challenge, I guess we don't have time to do that today, but you can show me your lab challenge next week. Your lab challenge will be that whenever you right click on a butterfly, please destroy that butterfly or remove that butterfly from array list. In your last week lab challenge, whenever you right click on the butterfly flies down. But this week, whenever you right click on your butterfly, please remove that butterfly from the game. You can show me your lab challenge next. That's it. If you have any question, please raise your hand. I can help you. Or else, have a good weekend. Oh, by the way, the student who did not show me your lab challenge at the beginning of the class, now you can show me. Or if you came here but I did not give you your participation marks, raise your hand. I will come toward you and give you your participation marks. Okay, let's